Okay, class. So today we're going to be working on chapter 14. Chapter 14, it's titled Rational Expressions and Equations. So pretty much what we're looking at is we're going to be looking with binomials and trinomials or polynomials and how they relate to each other in the form of a fraction. I know that for a majority of people, whenever they see a fraction, it's confusing, it's frustrating, it could be quote unquote a little scary or intimidating. Now, much more, it could also be more intimidating now that we are incorporating variables or letters into the concept of fractions. However, remember that the approach that we're always taking in whenever working with any mathematical problem is that it does not involve anything else than adding, subtracting, multiplying, and dividing. It's just a matter of following the correct sequence, and that's pretty much what math is about: adding, subtracting, multiplying, and dividing. So in the first example here, we're going to be looking at one thing that we have to keep in mind is that whenever you have a fraction, whether it has a variable or is just a plain fraction. Let's pretend that the x plus doesn't exist here. Anytime you have a zero in the denominator, it is going to be considered an undefined value. So therefore, we cannot have we cannot have values of x in this particular problem that will result in having us an undefined problem. So for example, if we look at the first problem here, we can see that the value that x cannot be -4. Okay, not +4, but -4. The reason for that is if we were to substitute this -4 into the original problem, we have -4 plus 4 gives us 0, or they cancel out, and thus it will result in 3 over 0, which is an undefined value. So one thing is that we're working with is those are called the limits, and eventually if you were to pursue higher level of math classes, those are the limits. That's where if you're graphing a function of with those particular terms, that's where there's a gap in that graph. But for the sakes of this class, let's just worry about not having an undefined value or ever a zero in the denominator, okay? Now, one thing to keep in mind again, also, just like when we were working with regular fractions, remember that if we were to multiply this fraction here by a factor of 1, remember that a factor of 1 is having the same numerator over the same denominator. What do I mean by that? Let's say, for example, if we were to multiply this original problem by 4 over 4. Remember that 4 over 4 is just the same thing as 1, right? So we are not changing the structure, let's say, or the value of the original fraction because we are multiplying by a concept of 1. So for example, that applies also to variables. So let's say here we had 4 over 4. So now let's say, well, what if we were to multiply by x over x? It's still the same concept, right? We are multiplying by a factor of 1, x over x equals 1. So let's see how that plays out. When are we going to use this in more advanced problems? When we get to the part, I believe it's the second or third section in this chapter, when we're going to be dealing with addition and subtraction of rational expressions or rational equations, when we're adding them, that's the part where we're going to be dealing to find the common denominator. So for the sakes of this problem, let's see how it multiplies by distributing this x into the numerator and then this x into the denominator. Again, keep in mind that it has to be the same number or variable over itself exactly. That means that the exponent also has to be the same. So if we were to distribute this x into the original problem here, we would have 2x to the second plus x, because remember, we're distributing this x to the first part here as well as to the second term, and it will be the same situation here in the denominator. So the 2x plus 1 became 2x squared plus x. The 3x will become 3x to the second minus 2x. Okay, so again, we're not changing the value of that equation because we are multiplying by a factor of 1. Okay, so one thing that goes hand in hand with the fractions is the concept of simplifying. Remember that we like to work with smaller numbers, or we want to simplify to the lowest terms. So in this situation here, we have to see what is the least common multiple, or the number that goes into both the numerator and the denominator, to reduce it, right? So in this case, we can divide the numerator by 2 and divide the denominator by 2 as well, to reduce it, or to cut it in half, right? So if you take half of 2, it gives you 1. If you take half of 4, it gives you 2 as an answer. A way to verify is multiply. Remember, here we're dividing, so in order to verify if we did the correct problem and we have the correct answer, we can go back with the opposite operation, which opposite of division is multiplication. So 2 times 2 gives you 4, and in the numerator, 1 times 2 gives you 2. 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. So yes, the 2/4 is a correct answer, but the best answer would be, in this case, 1/2, because it goes into lowest terms. Now, how do we apply this to trinomials and binomials? So we have to see what is the common multiple, right? What can be factored out? In the last chapter, we looked at factoring of a single, of binomials here. So what is the one term that can be factored out from 3x plus 6? Remember, we said that one number can be divided into the 3x and one number can be divided into the plain 6. Well, it would be a 3, right? So you are dividing this 3 into the 3x, it would just give you x, right? Because 3 divided by 3 gives you 1. And what do you get as an answer? When you divide 6 by 2, you get a positive 2. Okay, and in the bottom, again, we have the same thing, right? We have to see what number goes into both the 6x and the 3. It coincidentally happens to be a 3. So our answer here would be, how many times does 3 fit into the 6x? And that would be a 2x. And how many times does 3 go into 3? It's 1. Now, let's so that's the way you would simplify. Now, however, we can take it a step further, and remember from the previous example here, we said that anytime you have a number or an exact same variable over itself, is just a 1. So here, what we're going to do is, since given that the 3 is multiplying into the x plus 2, and the 3 here is multiplying into the 2x plus 1, we can go ahead and cancel out these terms. It'll become a 1. So your final answer would just be x plus 2 divided by 2x plus 1. Now, I know that some of you might be wondering, well, Professor, if you were able to cancel one term from the numerator with one term from the denominator, why cannot we cancel out the x with the x here? Now, I'll let you think about that for a second. Okay, so in this case, we were able to cancel it out because it was multiplying. Right now, the components or the terms inside of that parenthesis, they are being joined by the plus sign here. And the bottom term also is being joined or brought together by that plus. So you cannot separate these two terms and treat them as individuals so that you can cancel them out. The canceling will only work when the terms are being multiplied, not added. So please do not be tempted at canceling these two numbers here, these two variables here, or the 2 and the 2 here, and then just say that your answer is that. No, keep your terms, your variable plus a number, your coefficient variable plus another number here. Okay, so your final answer would be x plus 2 divided or over 2x plus 1. Okay, so here we have another example that's going to highlight how pretty much how we go about the simplification of a problem. So in this case, we're going to factor out whatever term or whatever number can be factored from the numerator. In this case, we see that it's a 4. So it's going to be x plus 1. And in the bottom, we can factor out a 6, which gives us for the denominator as 6 times x plus 1. So now we're going to see what number or what term or what binomial or monomial could be factored out or canceled or reduced. So here we have an x plus 1 and an x plus 1. We can go ahead and cancel it out, right? Because that's a factor of 1. So if you cancel it out, you're going to be left with 4 over 6, right? So this becomes this cancels out here. These two terms, the x plus 1 and the x plus 1 on the bottom, cancel out, and we come up with 4 over 6, which could be further reduced by half, right? So it'll be 2/3 as your answer, because you're dividing by 2 here. And remember, whatever you divide the numerator by, you have to divide the same number into the denominator. So the 4x plus 4 divided by 6x plus 6, when you simplify it by factoring and eventually reducing your fraction to simplest terms, gets just reduced to 2 over 3. Okay, so this might be a little too simple, yes, but it's just what I need you guys to understand is the concept of reducing. Okay, we're not going to get into too crazy stuff until this problem here. Okay, last week we looked at the difference of two squares, which is the number on the top. So to factor out the number on the top, remember that if we have a variable which is squared minus another number that could be squared, we have x plus 4 times x minus 4, right? We simplified or we factored out the top term. In order for us to factor out the bottom term here, the x squared minus 3x minus 4, again, a reminder is that we're going to do two parentheses, and we're going to look at the sign of the second term, or the second sign, I'm sorry, which is a negative. Whenever we have a negative here, these parentheses, one is plus and one is minus, correct? We're just reviewing the stuff from last chapter. And the first term here to the left of the plus or the left of the minus will be determined by splitting up this term into two equal parts. So in this case, it would be x and x. Now remember that we're trying to do the factoring of this 4 so that whenever we do the little smiley test, remember we were working on that last week, it gives us the middle term here of negative 3x. So this 4, the way to multiply into it would be 2 times 2 and 4 times 1. So now we are remembering that which one of these two combinations will give us a difference of 3 in between. So 2 and 2, there is no difference, exactly the same thing, and 4 and 1 have a difference of 3. So now it's just a matter of placing the 4 into which number combination here to give us the negative 3. So we'll put a 1 here in the positive and a 4 in the negative. And again, let's do the little smiley test to see if it's correct. So positive 1 times x give you plus 1x. X times negative 4 gives you negative 4x. Let's test it by combining them. So negative 4 plus 1 gives you negative 3x, which is exactly what we had here as the middle term. So this is the correct factorization of that trinomial. Okay, I'm going to erase this here so that it doesn't confuse us. And now we see which terms from the numerator can be canceled or simplified with the denominator. So we see that it's x minus 4 over x minus 4. So we cancel those two out. And our final answer would be just x plus 4 divided by x plus 1. And that is our answer. Okay, so let me zoom it out here so that you guys can see it. Okay, so let's continue with simplifying pretty much. Now we're going to be simplifying for the sake of multiplication with actually with the same concept or same principles as you would when you multiply two fractions. So I remember that when you multiply in fractions, and notice how I've used the dot here to imply multiplication. I don't want to put the x as we have traditionally been using it from the time that we learned the multiplication because I don't want to have it confused with one of the variables here. So I'll just put a dot here in between the two fractions that are going to be multiplied. So here, if we were to proceed in multiplying, remember that when you multiply fractions, you multiply in a horizontal way. So we have 4 times 14 will give us 56 and x to the third, correct? And for the denominator, we'll just have 3x times x, which gives us 3x to the second. Now, we got to simplify, right? How many times can the 3 fit evenly into 56? It does not fit evenly because 3 goes into 5 once, and it gives you 26. And the only way that 3 multiplied by a number closer to 26 would be by 8, and it gives you 0 remainder. So in that situation, there's no way to proceed in reducing. It will give you a mixed number. So here we would have, let me just double check that 4 times 14 gives you 56. 56. So the only term that could be reduced would be the x's, right? You have 2 here and you have 3 on the top. So your answer will be 56x over 3. And that is your answer there. Okay? Because you remember that when you're dividing variables with exponents, you're subtracting the smallest amount from the biggest amount of variables of the exactly of the same variable. I apologize. Okay, so now in this second example here, again we have Mr. Ojeda here complicating things for you guys a little bit, but I'm only following what the book is showing. So we are going to be doing 2 factorizations, one of the top of the numerator here and also of the denominator, and eventually we're going to see what it could be reduced with. So if we look at the second term here, the second fraction, a plus 3 over a minus 2 cannot be further simplified. So let's go ahead and just copy it or transfer it down here, which is a plus 3 divided by a minus 2. So now let's look at the a square minus 9. Difference of 2 square, right? This term is a square and that term is a square. So remember that it's a plus 3 times a minus 3. Okay, if you need a review of how to how to simplify with the difference of 2 squares, please review the chapter 13 video. That way it will show you how to proceed with that operation or that process. And we're going to be factoring this trinomial here, the a squared minus 4a plus 4. Again, we look at the second term, at the second sign, I'm sorry, and it's a positive. So when it's a positive, both parentheses are going to be the exact same as that first sign, so both of them will be a negative and a negative. And we said that the first term is a, which gets split into 2 equal parts. And now we gotta see which method of multiplying numbers to give you 4. So it's 2 times 2 and 4 times 1, right? Again, we have to keep in mind that we're going to be combining them, and if you add them together, it has to give you a 4, which obviously would be the combination of 2 times 2. So here we have a minus 2 times a minus 2. So now look, let me put parentheses in these, that way we know that it's the whole package deal here. Okay, so now I'm going to use a different color here so you guys can see what we're going to do. Okay, so before we multiply, what I like to do is, at least with our equations and monomials and trinomials, when you factor them out, I like to first expand or do my factoring and then see what can be canceled. I don't want to start from the beginning of the problem and start eliminating or canceling terms out if I know that I'm going to be making a mistake at the end. Okay, so what term from this numerator can be canceled with a denominator such as a minus 2 here? So we have this term cancels out with one of these two, and the a plus 3 here can be canceled with that other a plus 3. So we cancel it out and we cancel it out. So our answer would be a minus 2 divided by a minus 3. Okay, and again, please do not be tempted at canceling these a's or these minus and just telling me, oh, Mr. Ojeda, well, we cancel everything else, so our answer is 2 over 3. No, remember that whenever two terms, such as in this case a variable and a number, whenever they are being joined by a plus or a minus, we cannot separate them. The only way that we can go ahead and reduce or cancel out is when it's multiplying into another term. Okay, so for example, what I mean by that is, let's say we have 3x and 6x, right? In this case, they're multiplying, so you can go ahead and cancel your x's, and here you'll just have 1 over 2, right? Because you took you divided by 3 both the numerator and the denominator. Okay, so when it multiplies, you can, but when you're adding or two terms are connected by a plus or a minus, you cannot. Okay, and let me zoom it out so you guys can see the original problem, how we broke it down as a minus 2 or times a minus 2 divided by a plus 3a minus 3 times, which was a plus 3 in the original fraction up here, and a minus 2 on the bottom. Right there we just brought it over, and then we simplified or cancel out whatever terms could be eliminated. Okay, so here we have another example of the similar method that we're using right now. So again, we're looking at the top term here, the numerator. It's a difference of two squares. So when we simplify it or when we factor it, it'll become a minus 5 multiplied by a plus 5. The bottom term will remain a 6, right? Because there's no way to simplify it. And then we just copy the second fraction here of 3a plus 5. Okay, so now how do we reduce this now? How do we simplify it? Again, we look for the common terms. So in this case, it's a plus 5 that gets canceled out with this denominator with this numerator. Remember that it could be across as long as it's 1 from the top and 1 term from the bottom. That is exactly the same. So we cancel it out. Now we have a 3 here and a 6 that could be reduced, right? So if we divide the top by 3 and divide the bottom, the denominator here by 3, it will also be reduced to a 2. This becomes a 1. So our answer would be 1a minus 5 divided by 2, which is exactly the same thing as just having a minus 5 over 2. Okay, so learning how to factor is a key component in making your life a lot easier, especially with algebra. Again, just to review, this a squared minus 25, it was a difference of two squares. We have a minus 5a plus 5. We brought down the denominator 6 here, and then we just copied over the next fraction to the right side, and we determined what numbers could be canceled or what terms could be canceled out, and we came with the answer as a minus 5 divided by 2. Okay guys, so in this section 14.2, we're going to be looking at the division of fractions. Just a little recap, the rules for dividing fractions is that we have the first fraction itself, it's kept the way that it is, and then you switch that division sign by a multiplication sign, and you do the reciprocal of the second fraction. The reciprocal is pretty much just inversing the denominator to the place of the numerator and the numerator to the place of the denominator. So here it will be 10 over 7, and we reduce So 5 fits into 10 two times, right? So this becomes a 1, and that becomes a 2. So, and we multiply across, right? So 3 times 2 is 6, and 1 times 7, it's just 7. Okay, so our final answer is 6/7 here. Okay, so that was just a quick little rundown of the process of factoring, or I'm sorry, solving division of fractions. So again, keeping the same mentality here, we'll have 4/x multiplied by x/8, because we did the reciprocal of 8/x, right? So by us doing that, we can cancel this x with the top x, and we can reduce the numbers here, the 4 and the 8. You know what, let me switch this over to a times with a dot. That way I don't get confused. So we have 4 will be the common number that can fit into both the 4 and the 8. So this becomes a 1, and that becomes a 2. So in the top, or the numerator, will be in the answer of 1, and the bottom, the denominator, becomes a 2. So the 4 divided by x divided by 8x here got reduced to just 1/2. Okay, let's do the next example here. Again, it's the same concept. We just gotta maintain fractions in the first place. X minus 3, x plus 5, and it'll become a times, right? And it'll be x minus 3 because we did the reciprocal, and x plus 5. Okay, so what happens here now? Am I going to be multiplying the x times x and do the FOIL method? You could, if you want, for the sake of learning. However, to make your life a little simpler, I would just do this, x minus 3, and you have 2 of those. And given that we have the same term on both fractions, we can just have over x plus 5/2. Okay, if you want to do the FOIL method and do the x squared minus 6x plus 9, go ahead and do so, but I would accept answers as this here. Okay, now the next example here, example D, we're going to see what can we factor, or actually let's go ahead and do the reciprocals first. So we'll do a square plus 5a/6 times 18a and a square minus 25. Okay, so now let's keep in mind this. Now let's take it a step further. Let's factor out an a from this top term here. It would give us a plus 5 divided by 6, right? So I'm just taking it a step further to simplifying it by factoring an extra a, and I'm still doing the times here, and I'm going to just recopy this term here as 18a, and I'm going to factor the difference of two squares, so it'll be a plus 5, a minus 5. Okay, now what can we factor out? What can we cancel? Well, look, a plus 5 cancels out with the a plus 5 on the top here, and the 6 can cancel with the 18, right? So this becomes a 1, and that becomes a 3. So our answer on the numerator would become an a here. Don't forget that a, and you have a 3 and another a. So we 3a to the second divided by a minus 5. Okay, no further canceling of the a's here because these two terms are being joined together by a minus. Okay, so in this next section, we're going to be looking at the least common multiple and the least common multiple as it relates to the denominator. So keep in mind that you know how we were looking for the LCM, or the least common multiple between two numbers? That's the number that when you multiply the numbers, the number they'll have in common as you multiply them, or the multiples of each number. So in the case of 3 and 4, the least common term would be the 12 here. That's going to be this is going to be crucial in us being able to solve addition of fractions. Now, when we look at a more complex example, such as 12xy squared and 15x to the third y, whenever we're trying to locate their common, the least common multiple. First, we're going to look at the coefficients, which is in this case 12 and 15. And I went ahead and I did a little table that I like to do here between the 12 and the 15. So to find out which is the smallest number they have in common as you multiply out, as you do the timetable, let's say for each number there. So we look at, in this situation, it's 60, the common number. So part of the LCM between 12xy to the second and 15x to the third and y, it's going to be 60. However, now it makes it a little bit unusual. I guess if this is the first time you see this, the first set of variables here, it has x, y to the second. So in order for it to be similar or have something in common with the second set of variables, the first one is missing. I put here missing the extra x to the second, right? Because we have 1 here and 2 here. If you multiply this x squared to that x, it will give you x to the third. In the second example here, or the second set of variables, this one is missing an extra y. So this second term is going to be multiplied by an extra y, so that when you distribute this y into the x to the third y to the 1, it'll give you the y to the second that this one has, and in the first term, if you multiply by x to the second, it gives you the x to the third to make it similar. Okay, so I'm going to show you pretty much how that would be. Let me grab a second marker here. It's kind of hard to juggle different colors. Give me one. Okay, so we said that in the first set of numbers, the LCM between 3 and 4 is 12, right? So there it is. Okay, in the second example, we said that it was 60, right? Between 12 and 15. So I'll just go ahead and circle them so that I know what I'm talking about here. And if the first set of variables, so let me write down the the coefficient. Now, the first set of variables is missing an extra x to the second, so that it will be the same. So, and in the long run, it's going to be your LCM would be 60x to the third, right? Y to the second. And we'll put this to practice in another example as we see why is it done that way. In the next section, section 14.4. So one thing to just keep in mind is keep the idea of what is one set of numbers missing, so that it could be so that the second set of numbers with each other, they could have something in common. Okay, so we said the LCM between 12 and 15 is 60, and we need to multiply this x to the first times x to the second to gives us x to the third, y to the second, right? And this, so let's do this here. We needed 5, right? 5 times 12 gives you 60. And then here, you would multiply times 4. We have x to the third, so we just need an extra y. When you multiply, that gives you 60 x to the third y